Okay, in section B of this lab, we want to talk a little bit about relative and absolute addressing. So we already saw a bit of relative addressing. If we look at our Excel spreadsheet, remember when we did these percentages and we saw that as we dragged the formula down, the numerator changed relative to the location of the formula itself? Right? So this equation, or relative to the equation itself, I should say. So the numerator changes so that's always next to the equation. That's called relative addressing. There's also something called absolute addressing where things don't change. So this section of the lab, I talk a little bit about what those mean, and I'm going to let you read through those. But we can force a formula to use absolute addressing instead of relative addressing by using dollar signs. So let's see a quick example. I'm going to come over here and let's do a little bit of a change. So let's, kind of like we had before, we had this numerator, except let's divide by, I don't know, 50, right? And we see that the formula is going to change relative to that. So it's always going to be whatever the row of the equation is, that's going to be the numerator. What if we used a dollar sign, though, instead in front of that number 2? Dollar sign. Let's drag that formula down. Until we drag it down, nothing changes. Oh, wow. Look at that. It's no longer relative to the location. It's always going to be B2. It stays absolutely fixed. Now, I put the dollar sign in front of the number 2 because it's the rows that are changing. Notice our equations are all in column E, so that doesn't matter. And in fact, if I were to drag this to the right, what's going to happen is the 2 is fixed, but that letter B is not fixed. So as we move to the right, our numerator is going to move to the right as well. Okay, so if we look here, now the numerator's there. It's moved one to the right, just like our formula, our equation is moved to the right. But the number stays the same, so it's always row 2. If we wanted the column to stay the same also, we'd need to put a dollar sign in front of the column letter. So that doesn't affect this column, because in here the column hasn't changed anyway. But now if we scroll over, see how it's changed again? So that column is now fixed. So by putting a dollar sign in front of both the letter and the number in our equation, what we've said is no matter how this formula gets dragged around the screen or copied and pasted, because this also works for copying and pasting, Control C, Control V, right? There we go. No matter how we do that, nothing's going to change because we added those dollar signs. If those dollar signs weren't there, things would change. Okay, let's get rid of that. So in the lab, I give you a little example I want you to play with. So let's replicate this. I'll do this first one with you, and I'll leave these other 3 to do on your own. So what I'm going to do is I'm just going to make this little baby spreadsheet. So we have 2, 4, 7 going down. We can make a little tab, a new tab down here, a new sheet. There we go. And we said that was what? 2, 4, 7. 2, 4, 7. And then across was a 1 and a 2. 1 and a 2. So now we've replicated that spreadsheet. Now let's look at the first question. Let's put this equation in cell B2. Here's cell B2. I want to get rid of that quotation mark at the beginning. There we go, and then enter. And see, it's calculated that to be a 3. Let's see why. So it says we're going to take A2, which is blue, it's coded in blue, and we're going to subtract from that A1, so 4 minus 2 is 2. And then we're going to add to it B1, which is a 1, so 2 plus 1 is 3. So we get our little 3 right there. So here's the question. If we copy and paste or drag this into cell B3, what is the value of cell B3 going to be? So B3 is this one. Well, notice we have no dollar signs in our equation, which means everything's going to change as we move our formula around. So as we go down the column, we're still in column B, so the column letters aren't changing at all. But the row is changing by 1. We're going from row 2 to row 3. So each one of those numbers is going to get bigger by 1. So my prediction is that this cell, the equation is going to be A3 minus A2 plus B2. Well, A3 would be a 7, minus A2 is 4, so we'd have 3, plus B1, plus B2, which is 3, so we have 3 plus 3. I'm going to predict that we get a 6 here. Let's see what happens. There we go, we have our 6. And once again, if we can look, we can see the difference between these two equations. Notice the colors are still in the same order relative to our equation, right? They sort of surround our equation. But they've all shifted down by 1 because our equation has shifted down by 1. Right? So there's where they were originally. We shift down by 1. All of these shift down by 1. And so you can predict what's going to happen. Okay, let's look at the next one. You copy and paste or drag it into C2. What's the value of C2? Okay, C2 is right here. Okay, so from this spot, we're going to move it over 1. So our rows stays the same, right? We're staying in row 2. So none of those row numbers are going to change. But our column has changed by 1, right? So our column has gone from the B column to the C column. So each one of these column letters, since there's no dollar signs anywhere in this formula, each one of those column letters is going to change by 1. So my prediction is in this cell, we're going to have B2 minus B1 plus C1. So let's see what that would be. B2 is a 3, minus B1 is 1, so that's 2, plus C1, so 2 plus 2 is 4. So my prediction is we're going to get a 4 right here. Let's see what happens. Ta-da! Okay, let's see this in action. So once again, we're surrounding our formula. We're surrounding our formula. We move over, and we're still surrounding the formula with those 3 parts, but those 3 parts have shifted over with our formula. Okay, and finally, if we drag this into C3, what's going to happen? Right here. Now, we can actually look at this in one of 2 different ways. We can either think of this as dragging down from the 4, right? So we're drag down, or we can drag over. Either is correct, and they're going to give the exact same answer, and I'll show you that. We're going to see the exact same thing. So let's walk it through both ways. So let's imagine dragging over. Now, when we drag over, the row number stays the same. We're staying in row 3, right? But the column changes. So the numbers are all going to stay the same, but each column letter is going to increment by 1. So this is going to become, right here in this cell, is going to become B3 minus B2 plus C2. So B3 is 6, minus B2 is a 3, so we have a total of 3. 6 minus 3 is 3. Plus C2 is 4. I'm going to predict we get a 7 there by dragging over. Let's see. Ta-da! Right, so there's our formula wrapping around that. And there's our formula wrapping around that. Again, the row numbers have stayed the same, but the letters have changed. Right? So let's undo that and think about it coming down. Okay, so here the columns letters are going to stay the same, so the B, B, and C, but the row is going to change by 1. So instead of a 2, a 1, and a 1, we're going to get a 3, a 2, and a 2. Okay, so this is going to be a B3. B3 is a 6. Minus B1, or excuse me, minus B2. This is confusing even for me. Minus B2, so it's going to be that 3 right there. So 6 minus 3 is 3. Plus C2. Remember, we're going down, so the row number is changing. So 3 plus a 4 is going to give us a 7. Right? So B3 minus B2 plus C2 is going to happen no matter if we drag down or over. We always get the same equation, no matter how we approach it. Okay? So that first question right here, these are the answers for it. 3, 6, 4 and 7. Okay, so that's how to do these others. I want you to go through and predict, noticing what's staying the same and what's changing. So this next one, no matter how the row changes with the formula, that 2 isn't going to move because there's a dollar sign in front of it. That 2 stays the same. In this formula, the 1 stays the same, and this part, nothing stays the same. Everything is free to change. So I want you to predict what you think is going to happen, and then fill them in and move things around and see if you're right. And that's the only way you're going to learn these formulas. And formulas are the hardest part of Excel by far. And this relative versus absolute addressing is probably the hardest part of formulas. So this is the toughest part of Excel. And unfortunately, it's a really important part of Excel. And you will be quizzed on this for the next couple of weeks. So you really want to get this down, practice, send me questions if you have any, and see if you can figure this all out.